Okay, so let's move on to chapter 2, vector algebra. So in this chapter, I'm going to introduce you all two quantities or two parameters. The first parameter, we call it as a scalar quantity. Okay, scalar quantity. Okay, and the second parameter is vector quantity. Okay, so for scalar quantity, normally we only mention about their magnitude. Okay, we only mention about their magnitude. But for vector quantity, besides mention about their magnitude, we have to mention about their directions. Okay, what is the directions? So the example of scalar quantity includes, for example, the length. Okay, the length of a pencil. Okay, the temperature, body temperature. Okay, and also time. What is the weight? Okay, things like that. Okay, and for the vector quantity, okay, so the example of vector quantity will be like, okay, electric field. Okay, electric field. When you have antenna and that antenna radiate electric field, so you need to specify what is its magnitude and also directions. What is the velocity? What is the accelerations? Okay, so these are the example of vector quantities. Okay, so how we differentiate these two quantity when we want to mention them? Okay, so normally when we want to talk about when we want to represent a scalar quantity, for example A, okay, we will just use alphabet A. Okay, but for vector quantity, okay, you might need to talk about additional symbol. Okay, this and arrow above. So when you see these two things, you know their difference. Okay, this one represents scalar quantity and this one represents vector quantity. Okay, when you read some reference book, they don't use this one, but they bold. Okay, they bold their alphabet. Okay, but in our subject, mostly I will use this one. Okay, I will use this one because it's very troublesome. So I will use this one to represent that parameter is a vector quantity. In this subject, we are going to focus vector quantity that is oriented in three directions. Okay, first chapter you have learned. Okay, you have learned three types of coordinate system, right? They are actually the same, just we represent it by using different variables. Okay, so we will still represent the direction of the vector quantity based on this 3D coordinate system. Okay, so this is Z, this is Y, and this is X. Okay, so whatever vector quantity that is oriented in the Z directions, okay, oriented in the Z directions, okay, in this way, for example, in these directions, okay, we say that that vector is oriented in the K directions. Okay, when we specify this K, we have to put a little bit symbol here, okay, to represent that this is actually a direction. It's not a variable. Okay, when we want to mention a vector which is oriented in Y direction, okay, in Y direction parallel to the Y axis, we say that this vector is in J directions. And for the X, if you want to say that that vector is parallel, okay, or in the same direction as the S axis, we use the symbol of I. So can you differentiate all these variables? This here we got nothing. Okay, it's just labeling, it's just a variable. But here we got a small symbol here. Okay, so these small symbol actually represent the directions. Okay, this parameter is used to represent the directions. let's look at a very simple example of vector quantity. Okay, I have a vector, okay, and the value of the magnitude and also the direction of the vector is 5i plus 2j plus 1k. Okay, normally you will see vector quantity in this kind of star. Okay, it has I or j or k, or both exist at the same time. So what does and how does this vector looks like? Okay, so I'm going to construct a 3D coordinate system. This is your 3D coordinate system. Okay, what does it mean one by one? Okay, so 5i, it means that, okay, first of all, okay, from the origin, this vector A move 5 units in the I direction. Okay, in the I direction. So you move 5 units. Okay, if this is your 5, okay, you move 5 units in the I directions, right? So 5i is here. After that, it moves another 2 units in the j direction. So j direction is direction of y-axis, right? So you cannot start from here. You have to start from here, and you move it in the y directions. So you move it in the y direction for 2 units. Okay, 2 units. Okay, 2 units. Here. So this will be your 2j. So after that, what you will do? You will move another 1 unit in k direction. So k direction is directions of z. Okay, so you move 1 unit. Okay, maybe here. Okay, so you move 1 unit. So finally, the point stop here. Am I right? Okay, the point stop at this position. Okay, this is 1k. So your vector A is actually from the origin up to the final point. So you make a line and mention that this one is your vector A. Sorry, A. Okay, so this one is your vector A, okay, from origin up to the final point. So just now we mentioned for a vector quantity, it has direction, right? And it also got its magnitude. Now we only know the magnitude in each of the directions. We have to find the total magnitude, okay? One value to represent the magnitude, okay? The length of this line. Okay, so the symbol to find the magnitude of A is this. Okay, this is a symbol to find the magnitude. Okay, what we do here is, if this value represent AX, this value represent AY, and this value represent AZ, so the magnitude of your vector A will be equivalent to AX square plus AY square plus AZ square, and you have a big square root here. So this is a formula to find the magnitude of the vector A. So when you replace the value into the equation, it will be 5 square plus 2 square plus 1 square. The answer will be equals to 30 square root. Okay, you can leave your answer in this way, or if you want to find its value, it will be 5.48. Okay, things like that. Another parameter that you might need to calculate quite often in this subject is unit vector A. Okay, unit vector. Okay, so how to calculate the unit vector? So for unit vector, its symbol is this one. Okay, unit vector. Okay, unit vector. Okay, so the formula to calculate the unit vector is you take the vector A and divide it by magnitude of vector A. So this one is given by me just now, right? And you have learned how to calculate the magnitude. Okay, so for unit vector A, it will be 5i plus 2j plus 1k and divide by this square root 30. Okay, so you can leave your answer in this way, or you want to divide it one by one. Okay, so it will be square root 30 and square root 30 j and okay, we'll write k on here. Okay, 1k and k, they are the same. Okay, square root 30. Okay, so this is how you determine the unit vector A. Okay, and the symbol is like this. You have to remember the symbol. So far you have learned 3 symbols, right, for vector. So this is vector A. This is magnitude of vector A. And this is unit vector of vector A. Okay, they are different, so don't confuse. Next, we will move on to the addition and also subtractions of vector. Okay, so we have addition and subtraction of vectors. So in this section, you will be given more than one vector and you need to perform addition and subtraction. So now let's say if you have a vector A and it is represented by AX plus AY plus AZ. Okay, the other vector is BX, BY and BZ. So what will be the answer if I want you to find the vector A add with the vector B? Okay, so you can only add the magnitude that they are in the same directions. Okay, you cannot add this one with this one with this one. No. Okay, so meaning that okay, the final answer will be AX plus BX, and this magnitude will be in the I directions. Okay, for the J component will be AY plus BY, okay, which is in the J directions, and lastly will be AZ plus BZ in the K directions. So this is the formula that you have to use when you perform additions. Same as the subtraction. If A have to minus the B, okay, what you have to do? Okay, so because A is here, so you have to put the A first, minus BX, okay, and the AY minus BY and AZ minus BZ. Okay, so which one comes first, we have to put it at the front. A is here, so you have to put A here. Okay, but if B is here, B minus A, then all this part will be B minus A I J K. Okay, so it must be clear. Huh? Next, we move on to the multiplications of vector. Okay, so I will put in these sections. Multiplications of vectors. So for the addition and subtraction, I hope there is no problem because it is very direct. You just minus them, okay, according to their directions. Okay, so for vector multiplication, what we should do? Okay, so for multiplication of scalar quantity, it is very easy, right? For example, you have 5, okay, you need to multiply with a 6, okay, they are scalar, so it will be 30. Okay, sometimes you might not write it in this way, you might put it in this way, so you know automatically it's still 30. But for vectors, it is slightly different. So for vectors, we have two types of multiplication. Okay, so the first one is the dot product, and the second one is cross product. Okay, so what are the difference between these two? So for dot product, okay, that involve two vectors A and B, you will see a dot in between them. And for cross product, okay, you will see a cross in between them. Okay, so they are different, but both of them, they are called multiplications of vectors. So we are going to learn how to perform this one. Okay, how to perform this one. So we move on to the dot product first. So for dot product, so the formula used to calculate the dot product is A dot B, okay, will be equals to, you take the magnitude of A and you take the magnitude of B, and then you multiply with a cos theta AB. So this is an angle between vector A and vector B. So I will give you a simple example to help you understand what is the meaning of this theta here. Okay, so now if you have vector A equals to 3j and your vector B is equals to 4i, right? Okay, so in order to get the answer, okay, you have to find the magnitude of A, vector A. So this is very direct because you don't have the other component. So the magnitude will be 3 for A, and for vector B it will be 4. Okay, next, how we determine this one? So I have to explain it using diagram. So we use a 2D diagram here. Okay, we don't use 3D here in this case because we are only involved in the I and J, okay, which is the Y direction and also the X direction only. Okay, so for vector A, it is in J direction. So vector A is here in the J directions. So this is your vector A. Okay, and the magnitude is 3. Okay, for vector B, it is in the X direction. Okay, here, vector B, the magnitude is 4, right? So just now I explained this one is the angle between A and B. So look at this one. What is the angle between A and B? It is 90 degrees, right? So 90 degrees. So for this case, in order to get a dot product of A and B, okay, it will be 3, multiply with 4, and then multiply with cos 90 degree. Okay, so you put the angle into the equations, and the answer is 0. Why 0? Because cos 90 is 0, so you will get 0. Okay, so I'm giving you a very simple vector quantities, okay, only in one direction. So imagine now if you have a vector that is much more complicated, that has more than one direction. For example, okay, A equals to 6i minus j plus 3k. This is vector A. And you have the other vector, that is vector B, negative 3i plus 4j minus 2k. Okay, now I give you two different vector quantities, and I want you to find the dot product between A and B. Of course, in order to get the theta, right, the theta AB, you need to draw this one first, and also this one. Then only you try to find the angles. So what will happen? Okay, the angle might be very hard for you to find. Okay, I will show you. So this one, because you have 3 directions, okay, this is the 3 axis. So you need to draw the vector A and vector B. So for vector A, okay, I will label this one first, Z, Y, and X. For vector A, it is 6 unit. Okay, I just estimate it roughly. Okay, negative 1, positive 3k, so it might be here. Okay, so I just roughly estimate it. So this one might be your vector A. How about vector B? So negative 3, you will move in this way, negative 3, okay, plus 4j here, and minus 2k. Okay, maybe the point will be here. Okay, so this one will be your vector B. Okay, and the theta AB will be the angle between them. Okay, even though in this diagram it seems like it is 180 degrees, right? But we get this line based on estimation. We just roughly estimate, so we cannot determine the angle just based on our drawing. So it will, and from here, okay, it will be very difficult if you want to find this one. Okay, so here appears another alternative for you to calculate the dot product. So besides using this one, we can also use the other formula to find the dot product for vector, especially for complicated case, just like this one. So the formula is A, okay, dot product B will be equals to AX. Okay, I think you know what's the meaning of AX, right? And BX, you multiply them together, add together with the AY, BY, add together with the AZ, BZ. Okay, look at this equation. There is no more IJK, meaning that your answer will be in the scalar parameter. Okay, it is a scalar parameter. So let's try to calculate for this question. You have 6 multiplied with negative 3. Okay, and for the y, negative 1, 4. For the z, 3, negative 2. So your answer will be negative 28, right? Okay, so you don't have any more ijk here, even though your initial parameter, they are vectors, but after you perform a dot product, you got a value, okay, without directions. So for dot product, sometimes we will call it as a scalar product, okay, because at the end of the solution, you will get a scalar quantity. Next, we move on to cross product. Okay, cross product. We have settled the dot product, so it is cross product. So what does it mean by cross product? Cross product, it means that you put a cross in between two vector quantities. How you should solve it? Okay, so the formula to solve this one is quite similar as the dot product. You take the magnitude A, multiply with the magnitude B, and the difference is here. We are not using cos, but you're using sine. Sine AB. And you have additional one more parameter, which is unit vector n. Okay, so you have no problem on the definition of all these things, angle, but what is this? Okay, so this is actually a directions. Direction parallel to the plane that contains vector A and vector B. Okay, later I will explain to you what is the meaning. What is the meaning of this thing? Okay, by giving you simple example. Okay, so we define A to be 2J, okay, and the B to be 3I. Okay, very simple vectors to show you the meaning of this unit vector n. So we will use a 2D coordinate system. So A is 2J, so this one is your A. No, for this case, I think I have to show you using 3D. So I will wrap this thing. I have to use 3D, okay? Okay, 3D. Z, Y, and X. Okay, so we put this vector here. Okay, A2J. Okay, from here 2J. Okay, so this is 2J. And 3I is here. Okay, angle will be 90 degree in this case. Okay, it is very easy to identify. Okay, so angle will be 90 degrees. Magnitude, okay, is 2 and 3. Okay, now I'm going to explain what is this. So it is a directions. Okay, meaning that it is I, J, or K, or combination of I, J, K. Okay, sorry, this is shouldn't be a parallel. I should correct it. Sorry. Sorry, this one should be normal. Okay, normal. Okay, so unit vector n is a directions that is normal to the planes that contains vector A and vector B. So you have vector A here, vector B here. So the plane will be here. So I will draw you the plane. Okay, so this is your plane. So draw you another line. Okay, so what is plane? Okay, the plane must be parallel to the axis. Okay, so this one will be your plane, planar. Okay, plana is like a piece of paper. Plana is a plane. Direction normal to the plane. Normal means what? Okay, this is normal. This one will be the normal directions. Normal direction, it means that this direction will form a 90 degrees with the plane. Okay, so if according to this case, the normal direction is k directions. So this one will be k. Okay, so the answer for this case will be 2, 3 sine 90, and the direction is k. So the answer is 6k. Okay, this one will be your answer. But same thing, okay, we cannot always apply this equation because it is very difficult for us to determine the angle, and when our vector has more than one direction, it will be very difficult for us to find this one as well. So we have to use the other formula. So the other formula is IJK here. Okay, if you still remember this one, A is we put it at the front, right? So you have to put AF first, and then AY and AZ here. Okay, BX, BY and BZ here. Okay, so do you remember how to solve this one? You learned this thing before, right? So how to solve this one? Okay, so for the I component, you have to hide, okay, this column and this row. So now we left these 4 components. Okay, so now for I component, AY multiply with the BZ. Okay, and now you have to minus BY multiply AZ, because just now we hide the I component, right? So this one will be I. You clear? This one multiply this one minus this one multiply this one. Okay, next we move on to the J component. So we have to hide. Okay, we don't look at this column and also this row. So now it's 1, 2, 3, 4. Okay, the special thing is you have to put a minus here. AX BZ minus BX AZ. And this is a J component, and you have to remember this one must be negative, and last one will be the K component. You hide this row and this column. Okay, so it will be AX BY minus BX AY. Okay, this one will be K. So this is how you solve the dot product. Cross product. So at the end of the solution, you will find that your answer is actually vector quantities. Okay, just now it is for dot product, it is scalar quantity, right? So for this case, it is vector quantity. You have I, J, K component. Okay, let's try to practice it on one example. If I give you my A, and my B is find the dot product. Cross product. Okay, for vector A and vector B. So you will use this one, right? Okay, you will use this one. I don't encourage you to memorize this one because it is too complicated. So I prefer you to fill out these ax, by, bz, all these components and learn how to derive it yourself. Okay? If you memorize it, one of it wrong, then the answer will be wrong. Okay? So now you plug the correct value into its log. Okay? So this one will be 6, 3, 5, and so it will be 2. You have to insert the negative as well. Okay? And negative 5 is here. Okay? So this is how you arrange each parameter into this matrix. Okay, so now how to solve it. Okay, so this one will be negative 15. Okay, sorry, negative 15 minus negative 15. Right. Okay, when you have 2 minus, it becomes positive. And this one will be 6, negative 30 minus 10 for your J. And next one will be you hide the K, right? Okay, so no more I component. Okay, so this one will be actually 40 J minus 24K. Okay, so this one will be your answer after you perform the vector cross product. Okay, so sometimes you might be asked to find the magnitude. Okay, after you perform the cross product, so what you should do? Okay, same thing, you just take the 40 and then you square it, and you take the negative 24, you square it, and then it will be square root. The answer will be 2176. Okay, so this one will be the magnitude after you perform the cross product. So actually there is a meaning for this one. Okay, after the value actually represent the area of the parallelogram which is formed by the vector A and vector B. Okay, so I just give you a very simple illustration. For example, this is your vector A. Okay, I just estimate it. I don't really draw it properly. So this is your vector A, right? And this is your vector B. Okay, this value will represent the area of this parallelogram. Okay, so area. Okay, area, area. Okay, so by using the cross product, you can actually find the area, okay, of a parallelogram. Okay, so this is all about how we perform the cross product, multiplication of vector. Okay, now I'm going to introduce you all a new term that sometimes you might need to find it. Okay, this is position vector. Okay, so for position vector, sometimes we will use the symbol of RP. P is a point. Okay, and position vector, of course, it is a vector quantity. So how to find the position vector? Okay, so this is a 3D coordinate system, and let's say now you have a point P here, and its coordinate is xp, yp, and also zp. Its coordinate. So this is z, this is y, and this is x. So position vector, okay, is actually a vector that linking your origin and point P. Okay, so it is from origin to point P. You need to find this vector. So in order to get this RP, okay, you have to take the value here and minus the value here, okay, which means that your SP minus with the coordinate of the origin. So for origin, the coordinate is 0, 0, 0. So it will be minus 0 I, okay, plus YP minus 0 also, plus ZP minus 0 also. Okay, so for this position vector, okay, it will be actually fully depends on the coordinate of point P, right? Okay, so this is the definition of position vector. Okay, so the next term is distance vector. Okay. Okay, so for distance vector, okay, distance, right? So it normally involves 2 points. For example, let's say you have point P and point Q. So I will construct a 3D again, 3D coordinate system. Okay, 3D coordinate system. Let's say your P is here, okay, and your Q is here. Sorry, I shouldn't put this thing here. Okay, they are just point, so I shouldn't put this one. This is point P, this is point Q. So both of them, they got their own coordinate, right? Okay, and for this one, it will be XP, OYP, and ZP. Okay, so these are the coordinates. So distance vector will be actually a line, a vector that linking these 2 points. Okay, if it is PQ, it means that the vector is oriented from P to Q. Okay, you have to remember PQ means P to Q. Okay, how to find the distance vector of PQ? You are going to take the coordinate, okay, of the short line ending point. Okay, you just imagine this is your starting point, this is your ending point. So you have to take the coordinate of ending point minus the coordinate of starting point. So it will be SQ minus SP. Okay, very similar to the position vector. Just for this case, you are not comparing with origin, you're comparing with the other point. So this one will be YQ minus YP, and for the J component, and last one will be ZQ minus ZP. Okay, what will happen if it is QP? Okay, QP, it means that from point Q to point P, so the arrow will be in reverse direction, okay, in this way. And the formula, of course, it will be different. So it will be SP minus XQ plus yp minus yq and plus zp minus zq. So you have to read the question properly and identify which one they want. Okay, so this is the distance vector. I think it is very direct, so I think I don't need to give you any values for you to calculate. You just need to understand the concept. So this is all about chapter 2. Okay, how to perform arithmetic operations that involve the vector quantity. So you have to complete the tutorial. So tutorial, you can refer to tutorial folder. So there are highlighted questions here. Okay, highlighted questions here. So I need you to solve this question and submit to me in the try to finish it. So we can either discuss or you can straight away submit it in the tutorial section. If you have any question, you can ask me in the tutorial section. Okay, so this is the lecture for week 2. Thank you.